Now that we've had a gentle introduction into classes and how to instantiate objects from them, we are going to take a little bit closer look at some of the specifics that we've glossed over so far. So what we have is I've created a couple new classes for us to use, all kind of based off of the duck class that we had initially, but with some subtle changes. And so I've called them duck v1, so version 1, duck v2, that we're going to be working with. So I'm going to go ahead and open up duck v1 and just notice some differences that are here from what was in my initial class. I can take a moment to look at this, and what I will realize is that I'm missing one big thing, and that is my constructor. If I pull up duck.java again, you'll notice I have this constructor here, which we kind of glossed over how this works and what it's doing. But now we're going to dive in a little bit more into what it, why it's needed, and if it's not there, what happens. So we're missing this constructor. What we'll notice, though, is that we have the rest of the things that are the same in this class. And we'll point out a couple of them. So first off, let's talk about these variables here at the top. So these are what many will refer to as like attribute variables or instance variables. These are variables that each object that I make will have their own set of. So each new duck that I make, that I instantiate from my duck v1 class, will get these three things: a name, an ID, and an occupation. Depending on what I do, they'll have different values, but they'll each have those things. And then these are two methods that I can call then on my objects once I create them, which I'm not going to really worry about right now. So what we'll notice, though, is that there's no constructor to be found. And so the question is, of course, well, what do I do if I want to create an object? So we're going to go ahead and try that. So I'm going to go ahead back to my duck developer class and just delete everything that's in there. So last time what we did was we realized that we could make a new duck by calling it whatever we wanted, just duck1, by using the keyword new, which allocates space for me in the heap, and then by calling this constructor. And so the constructor has the same name as the class, and what it essentially is doing is returning an object of the class type that we're using, that can then be stored into that memory location in the heap. So in this case, we had to include three things. We had to include some name, we had to include an ID, and we had to include an occupation. Okay. Now here's the thing: is that I'm not working with the duck class right now. I am working with duck v1. And so I'm going to create objects from duck v1. The first one is, I'm just going to call it duck1. Oh man, I'm really struggling today. Duck1. And what I'm going to set equal to is new. And the question is, I don't have a constructor to use. So I'm going to try and call a constructor. It's still going to be called duck v1, which is the name of the class, but I don't know what parameters or arguments should be put in there. So I'm just going to save this. That's going to be good. And then let's go ahead and print out the information I know about it. So we glossed over this last time as well. So whenever I want to call a method on an object in a class, if we go back and look, I've got one of these right here, my toString method. Now, toString method is a special method, which we'll spend more time talking about later. But just suffice it to say right now, what it does is that I can call it upon an object, and what it's going to return is a string. That string is going to look like name, ID, and occupation. And so the way that I do this is so I'm the system.out.println, and then I'm going to use what's called the dot operator. So duck1 dot, and then toString. Takes in no parameters. So it's weird to think of this as an operator, but it is. It takes in two arguments, one on either side of it. The first one is the object in which we're doing the calling upon, and the second one is the method that we're calling. So upon duck1, I will be calling the method toString. So this is an operator. It takes in these two arguments, one on either side of it. So if I save this, and I go and I run this. One moment. Computer. Oh, it's on my desktop. Desktop and computer science A, and we're in unit 2 now. And I will compile my duck developer.java. All right, it worked. Fantastic. Then I will actually run it, and we will see that I did in fact create a new duck, a duck v1 to be specific. And so the reason for this, so the reason that this happened, is because every class that I have, if I don't make a constructor for it, I will be given what's called the default constructor. What the default constructor does is it does the most basic of things that it can do. In this case, it's going to create a new object, and the variables inside it, the attributes within inside it, are just going to have whatever values were predefined for it. So in this case, what did I print out? Empty string for the name, an ID of 0, and an occupation of empty string, which is exactly what my initial state variables had in them. So there will always be, if I do not create a constructor, this default constructor available to me. It takes in no parameters and just creates a new object with the minimum effort possible. Okay, so that was just a quick example to show that. So the question is then, what if we actually want to make some constructors that are a little bit more useful? So I'm going to dump duck v1. It's served its purpose for me now. And I'm going to jump over to duck v2. And what you'll notice is that there's substantially more things in here now. So let us point out a few of them. So if I look at my state variables again, it looks like I've got 4 variables now. I added a new Boolean variable to determine whether or not the duck is hungry, which is obviously an important thing I'm going to want to know. And then we'll notice that I have not 1, not 2, but 3 constructors available to me. So these 3 constructors are all a little bit different. We'll notice what they have in common, though. Each of them has in common the fact that they are public and that their name is duck v2. Because I'm working with the duck v2 class, all my constructors are going to have that name duck v2. The big difference between all 3 is the fact that they will take in different parameters. Name just takes in a single parameter. Name and ID takes in those 2 parameters. Name, ID, and occupation takes in those 3 parameters. Okay, this is a process of what's called overloading. I had an initial constructor. It was the default constructor, which if I called it with no parameters, it would run and it was no big deal. I have now overloaded the constructor. This is true for any method. I can overload functions as well, or methods in Java. What that means is that I have functions, or in this case constructors, that have the same name, but their only difference is that they do something differently because their parameters are different. So if I go back to my duck developer class and I get rid of all this again, and now I start declaring things of duck version 2. So let's just call this duck1, duck. See, I did that equals again. I don't know why I keep doing that. Duck1, and this equals new. And then let's go ahead and use that default constructor. So that default constructor is going to be duck version 2. And so that first one just took in a name. So in this case, if I want to give it a new name, I can do that. We'll call it Alan. And then semicolon. And so this creates a new duck for me. If I save this, I'm not going to print out the information. Actually, let's go crazy. Let's print out the information. So duck1.to string dot job. No, what am I doing? And I actually need to print this out. System.out.print line. That should do. Okay, so I've created a new duck. Name's Alan. Gonna print it out. Let's see what happens. Compile. Oh, run. All right. So, okay. I forgot to do something. we'll have that conversation now. That's cool. Okay, so first off, number one is that I'm in the name constructor. So this was something that's printed out. So if I go back to Duck v2, what I'll see is that in this first constructor, I have the system.out.print line. I'm in the name constructor. Okay, so that was just to let me know that that's the constructor I'm in. So perfect. So I print that out. That's all well and good. And then I made a mistake, kind of. So then it prints this kind of garbage out. So Duck v2 at, and then this. If you want to take a guess at what this is, it's kind of a memory location. So here's the thing, and this is what I was kind of not saying before, was the fact that toString is a special method. Any object that I create, any class that I create rather, and I create an object from it, there is a toString method that exists for that class. Last time what I did in my other duck class is that I overwrote it, right? I created a new toString method that printed something else out. So what this does, what's the original toString method, what it does is it prints out the memory location of it. So since I forgot to actually put that in there, that's what's printing out, the memory location. It's worth noting, so that's a duck, it's there, fantastic. Maybe it's worth copying and pasting this over toString. This. We'll just slap this at the end. Okay. And now it'll work the way that I want it to. Sorry, my apologies. Oh yeah, I changed the, okay. Nothing like doing it in one take. Alright, so let's, go ahead and run this again. Haha, okay, perfect. So Alan, so what we'll notice, okay, is that the other two attributes here that I'm printing out, the ID number and the occupation, both are just taking the values of what were already set, because this constructor changes nothing about them, which is fine. So the reason that I use this constructor, or rather that Java picked this constructor, was because it only takes in the one parameter here. It only takes in one string, which is the name. If I were to go, and let's go back to Duck Developer, we'll make another duck. This is duck v2, and duck2 is going to be equal to new duck v2, and we'll give it the name of, I don't know, Steve. Perfect. What a great name. It's an okay name. This is currently using the same constructor that I had before. What if I want to use the other constructor? I can include another piece of information, which is the number 3, which is the ID number. And so if I save this, and I don't really care about the information about the duck right now. If I save this and I run this, what I'm going to see is that, of course, it is going to run or use rather a different constructor. Okay, so remember, I overloaded this constructor. I now have 3 different constructors that could be used here in this situation. The way that it knows which one to use is by how many parameters I'm giving. In this case, the first one, I gave it a string, and the second one, I gave it a string and a number. If you want to guess, if I give it a string, a number, and then another string, it'll use this third constructor, which is great, which is exactly what I wanted to do. What's worth noting here is that Java can differentiate between these 3 constructors because they take in a different number and different type of input, of parameters. If I were to create another constructor that, let's say, just takes in the occupation, so just takes in a single string called the occupation, it would not be able to differentiate between the current constructor that I have that takes in a name and one that just takes in the occupation. If they both take in a single string, Java doesn't know which one I want to use. And so the only way I can overload a constructor like this, or a method in general, is if the number of parameters is different or the types of parameters are different, which is important here. Otherwise, there just has no way of knowing. We could look at it and obviously tell, oh, well, okay, he said engineer versus he said, Rob. you know, obviously we know which ones those would be. The issue, of course, is, ambiguity. Like, what if it was Taylor? Now the spelling might give that away, I guess. But point being is that we don't know. And so I can only overload using, specific or different types of either variables or different numbers of them. Okay, so let us go back and try out another thing. So just out of curiosity, if I try to make another duck, and we're on to duck 3 now, I would like to make another duck, version 2, and I would like to please use the default constructor again. I've had fun with creating these names. I would just like to make another duck. Nothing special about it. Just use a default constructor. And so if I do that, if I go and I run, and I am going to get a compile error. This is a great error. This is just a fantastic error for a number of reasons. So number one is what we will notice is that it says no suitable constructor found for duck v2. Okay. Specifically, it did not find a constructor called duck v2 that took in no arguments. What this means is that whenever I create constructors for a class, the default constructor goes away, unfortunately. So I cannot call it. There was no constructor that they could find that took in no arguments. Now, that being said, I could, if I wanted to, write a new constructor that takes in no arguments, and that would be fine. I could still call that and know which one I wanted. Here's the next thing that I think is really nice. Java's helping me out big time here. It's saying, hey, here's where you did it. You screwed up on line 5. There it is. But just so you know, there were all these other constructors you could have used. Here's one. It takes in a string. Right? There was another one that takes in a string and an integer, and there's a third one that takes a string, an integer, and a string. Right? None of these were applicable for what you wanted because the arguments that you tried to give did not match. So that was actually extremely helpful. Thank you, Java. I appreciate that. And so it's telling me that I have to match one of these versions to actually be able to use the constructor. Okay, so that's constructors. That was a lot about constructors. We of course will circle back to this later on in a different unit, but that's kind of what I need to know right now. Yeah, okay. So let us then, I want to talk very briefly about a certain type of method. And that certain type of method would be what we call void methods. I have several void methods. We're going to focus on 2 of them right now. So when I talk about void methods, well, I'm talking about our methods. Oh, I highlighted a little bit too much. Actually, all these are void methods. Look at that. Okay, so when I'm talking about void methods, well, I'm talking about our methods that say public and then void and then, the name of whatever the method is. So this keyword right here is telling me what the function is going to return. So actually take a step back for a second. This is called the signature line of my method. There's going to be a lot of good information in here. The keywords are obviously things like public or potentially private, which we're not going to focus on right now. Void is what we're focusing on right now, which means that I'm not returning anything. But I could have other methods that do return something. For example, our toString function returns a string. And so void methods will return nothing. And it's really important to notice the difference between returning nothing versus printing something out. The 2 functions I want to focus on right now are the feed function and the produce waste function. Those are obviously 2 things that ducks do a lot of. And what we'll notice is that nothing actually gets returned in the program. Yes, they both do print something out to the console, but that is not the same as returning something that I can use as a value in my program. And if that's unclear, that's okay. We're going to get to things that return things shortly. So let us look at what these do for me. So I've got my feed function, takes in no parameters, which is great. So if I want to go back to Duck Developer, Alan is a little bit hungry right now. Can I go back for a second? I don't have any way of determining if he's hungry or not. But we're going to go ahead and feed him. So the way that this works is, man, I really should have some type of function. All right, fine, we'll write it really quick. We'll just make a function that is also void. So public void. We're just gonna go with is hungry. Just tell me, please, is my duck currently hungry? It'll take in no parameters, which will be great. And what we're gonna just system.out.print, and it's going to be something to the effect of this .name, which you don't have to worry about what that means right now. Is hungry, colon, space, and then add to that this dot hungry. So this is going to tell me whether or not my duck is currently hungry. So save that. Nice. Probably made an error. We'll find out here in a second. And let's check to see if Alan is hungry. So we're going to call duck1 dot is hungry. Okay, so this, like we already kind of talked about, is the fact that this is my dot operator. I'm going to call this method on my duck, and it is going to print something out. It returns nothing. So I'm not storing anything from it. It's not actually doing anything in the context of my program that I can see. The question is whether or not my duck is hungry. And so I'm going to go ahead and save this. And am I printing anything out? No, I'm not. Okay, great. Go ahead and compile. I forgot to take out this, which would make sense. All right, save. And one more time. Marvelous. Okay. I'm in the name constructor. Great. Name and ID constructor. Awesome. Alan is hungry. True. Okay, so let's feed him. Okay, we can do that. We can say duck1 dot feed, which was my other method. So go back and look at duck v2, and let's see, feed was right here. So feed is a method that I can call on an object. It is void. It returns nothing. But if I look at what it does, is that it's going to change whether or not I'm hungry if I feed him, and it's going to print this out, which is great. And so if I go back and I save this and I run it, and I run it, and I run it. All right. Alan appreciates my generosity. Thanks, Alan. How about I check to see if he's actually hungry still? The answer is hopefully not. I fed him, right? He shouldn't be hungry. Marvelous. Alan is no longer hungry. Okay, so what these void methods do, typically, is they do something kind of behind the scenes. In general, or actually not in general, specifically, this case, what I'm doing is I'm changing whether or not I am hungry, or rather, if Alan's hungry, if my duck is hungry. By feeding him, I am setting my hungry value to be false. Okay, and then I'm printing this out. Okay, so it can change the state of one of my variables in that specific duck. Obviously, it does not change anything for any of the other ducks. It just changes something for this specific duck. So I changed whether or not he was hungry by feeding him. He is no longer hungry. However, in a second here, after I feed Alan, obviously, then he's going to have to take care of some business. So let's go ahead and do that. So duck1 dot produce waste. Marvelous. And save. Actually, and then let's check to see if he's hungry. Duck1 dot is hungry. Nope. And we'll go and print this out again one more time. Okay, let's see. So I printed my constructors. Great. Alan was hungry. I fed him. Alan appreciates your generosity. Alan is hungry. False. Good, because I just fed him. Alan feels much better now, albeit a bit hungry. So then we test to see if Alan was hungry, and true. Okay, so these functions, is hungry, feed, is hungry, produce waste, is hungry, don't return anything. They are void methods. However, what they do is potentially change things or check things behind the scenes. So in this case, my feed function was changing my hungry to be false after it was true, or just change it false if he's false. We just keep feeding him, he'll just remain not hungry. And then I produce waste obviously turns hungry to be true, but for that specific duck. Okay. That's everything I want to say about void methods. I want to say one more thing, though. Let's see, one more thing really quick. Let us try to do this. Okay, so you guys know that I can make a new duck here. We're going to call it duck 3. If I did this, if I stopped right here, that would be fine. I have just declared duck 3. I haven't done anything with them. Okay. My question is, what happens if I try to duck 3 dot is hungry? Okay, so I have a duck that I declared. Here he is. I now want to check to see if he's hungry. I'm going to say this. Actually, let's do this really quick. Just to prove to you that this will compile, no problem. Let's go ahead and compile it. Fine, no big deal. And then let's go back and clear this out. Okay, now let's see if he's hungry. Okay, don't even get to the next part. I got an error. So variable duck3 might not have been initialized. Fair point, Java. You got me there. All right, duck3 does not actually have a value. Okay, it's not pointing to anything yet. And so what this is called is, it actually didn't use the words I was expecting it to. So what this is called is what's called a null pointer exception. I tried to reference something that isn't actually there, right? In theory, duck3, which is the name of one of these ducks, should be pointing at a place in the heap where my information is stored. It is not, because it doesn't exist. And so when I try to call something on it, it's going to try and check to see is hungry for that thing that's pointing at, which is not there. And so that pointer is pointing at nothing, which means that it is null. So it's a null pointer exception. Maybe not technically, but really it kind of is. We will have other times in this situation where we will get actual null pointer exceptions for different situations. Java's just being a little bit clever right now, just saying, hey, you didn't initialize it. You screwed up. Okay, so yeah, I think that's everything I want to talk about as far as constructors and talk about void methods. When we come back to the next video, I'm going to talk about so void methods with parameters in them, and then also non-void methods, so methods that actually return something, what I can do with those. So until then, that's everything we need to know about constructors and void methods, and we will return again soon.